With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Each of the blocks shown in figure has mass 1 kilogram. The rear block moves with a speed of 2 meter per second towards the front block kept at rest. The spring attached to the front block is light and has a spring constant of 50 Newton per meter. Find the maximum compression of the spring. So let the first block be block A and the second block be block B. And the first block is moving with a speed of 2 meter per second initially. When the block moving with 2 meter per second contacts the spring applies force on both the A block and the B block, and the A block velocity gradually reduces and the B block velocity increases while the spring is compressing. And at the point of maximum compression, V of A will be equal to V of B for maximum compression. X is the deflection of the spring, so at X max, VA will be equal to VB. So it is at this point that we need to calculate the value of X. Because of the presence of a spring, there won't be any loss of energy over the system, which consists of A and B and the spring. So the energy E of the system initially will be equal to energy at the point of X max. Initially, only the kinetic energy of block A is present. Therefore, initial energy is equal to half into m into UA square. At the point of maximum compression of the spring, both the velocities will be same. Therefore, half m VA square plus half m VB square plus half into K into X max square, where X max is the maximum compression of the spring. Since VA is equal to VB, we can denote them as simply V. Therefore, half into m into UA is 2 meter per second. Therefore, 2 square is equal to half into m into V square plus V square plus half kx max square. After rearranging, we get half k x max square is equal to half into m into 2 square minus 2v square. Using this formula, we can calculate the value of x max, but we don't know the value of v yet. This can be calculated using the conservation of linear momentum principle. So in this system, we can say that no external force is acting. Therefore, sigma f of system is equal to 0, and hence the linear momentum of the system Pi is equal to the linear momentum of the system at the point of maximum compression of spring. Since initially only block A has a velocity v, therefore initial momentum is equal to m into UA. The final momentum is equal to m into VA plus m into VB, or we can simply write it as 2m capital V. So m and m can be divided. Therefore, capital V becomes equal to UA by 2, which is equal to 1 meter per second. The value of V can be put in this equation, and therefore we get kx max square is equal to m into 2 square minus 2 into 1 square. Inserting the values, k is 50 Newton per meter into x max square is equal to mass is 1 kilogram and 4 minus 2. This implies x max square is equal to 1 upon 25. Therefore, the maximum compression of the spring denoted as x max is equal to root of 1 by 25, which is 1 by 5, or in decimals it is equal to 0.2 meter. This is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.